Patrick Cook here. Welcome to session 4 of Mandelbulb Epic Rendering, a tutorial series where we're talking about how to be able to get out of the Mandelbulb3D application high resolution still images. Okay? Now, in the last session, I was talking about a couple of use cases. One would be that we want a very large physical print, all right, and where we want to be able to give the print vendor an electronic image that would be very close to, or at least above, the number of pixels that they would require to get a good quality print at whatever size that we're looking for. So physical print would be one use case. And I also talked about the other use case where the more pixels you have, the higher the quality, up to a point where people start throwing pixels away, or an electronic monitor throws pixels away, and then you're wasting pixels, okay? But I also talked about how it is far better to eliminate pixels, to dispose of pixels, all right? Let other people dispose of pixels, or let a monitor dispose of pixels by downscaling it versus trying to upscale it, where you've got somebody else that's trying to interpolate or add pixels into your image. You really don't want that, okay? Now, I also promised that I would talk about a third use case that really is kind of creative, okay? All right, tell you what, let's get the whiteboard up here. All right, and let me see if I can kind of illustrate this for you. Clear this, yeah, okay. Now, let me get my stylus here. Let's say, oh, hang on. Let's get a decent color here. Let's say that I wanted to make an electronic image, all right, and I want to run this into a video editor, and I want to be able to use my video editor to pan, all right, left and right, up and down, and zoom in on that graphic. Now, let's say that I wanted to produce a graphic that would be standard high definition. Let's say 19,200 by, let's see, 1080, something like that. Okay, 1080, okay? That would be referred to as high definition, all right? 4K, we do what, 38,400 by what, 2160, something like that, okay? But just, okay, the numbers, you know, the height is not really relevant. Now, let's say that I wanted to take my high definition video and I wanted to pan around on an image. Well, if I was to put a standard high definition 1920 by 1080 into my timeline of my video editor, well, I've got nowhere to pan. All right, because if I was to pan, all of a sudden I would pan off of the image and I'd have a black bar over there. All right, so so when I have a high definition still image in my timeline, which is going to render out at high definition, I've got nowhere to pan. Now, I could zoom in and out. I could zoom in, but I couldn't zoom out, because I zoom out and all of a sudden now I'd have black bars all around my image. So if I wanted to be able to pan around, what I would have to do is to put a graphic image, you know, that's maybe twice the height and the width of a high definition. In other words, what if I was to put a 4K, which is 38,400 by 2160? It's twice the size of HD. All right. If I was to put a 4K in there, now I've got room where I could pan around. And if I zoomed in, well, I still have pixels to work with. So what if I was to put an 8K in there? All right. Now I've even got more room. So here's where I'm going with this. What you could do is you could create an electronic image that had an abundance of pixels in both the width and the height. An abundance that would be greater than your final presentation, that would give you the ability to pan around, to simulate animation. Simulate animation by panning up and down, left and right, as well as being able to zoom in and out. All right, and it's actually pretty cool. But in order for you to be able to do that, you have to put enough pixels into the image where when you pan, which is effectively shifting the image over, okay, so that you're panning, all right, but you want to be able to shift it over and still have plenty of pixels left when you shift it over, all right, so that you don't wind up shifting this thing right out of view and then you get a big black band. So a use case, kind of a creative use case of being able to create a large rendering, all right, high resolution graphic still, would be that you can simulate animation, all right, in a video, all right. Now, if you pull that off, you can actually have a very interesting presentation that appears to be an animation, but it does not consist of many frames, all right, that you would normally have to create in order to simulate motion, all right, and that would be the animation project that we talked about in tutorial series number 1, okay, where what we spent like 153 sessions and talking about how to make these keyframes and how to get smooth animation motion. Well, with this trick right here, you could actually get a fairly decent looking and realistic looking simulated animation simply by moving the image, as long as you have enough resolution where you don't actually run the image off of the screen and then produce black bars, all right, which is not good, all right, it's not going to look good. So what I wanted to do in this session is really just kind of introduce you to the idea of creating a large, high-resolution graphic, all right, that could be utilized to simulate animation in a video editor, all right, by moving the graphic around, all right, moving the graphic around, all right, to simulate this motion. But what you don't want to do is you don't want to move that graphic so far that you create a black band, okay? In order to do this, you want to have a graphic that is bigger than your view of the view of your camera. And now, if you move it around, you're simulating motion or animation. Okay. Now that's, and you know, you also can zoom in and out, all right, without running out of pixels. So we'll experiment with that in this tutorial series as well. All right. All right. So okay. So I think you got a pretty good handle on 3 use cases that I see. All right. And one is a large print. The other is a high resolution, so that devices or people downscale rather than upscale your image. All right. Downscaling is less destructive of quality than upscaling. And also that you actually could simulate a animation without all the work of all those keyframes and all the stuff that goes into producing rendering the keyframes and then bringing them into your video editor. Okay. All right. So with that said, let's get a coffee, and we'll pick this up in the next session, session number 5, and we'll go from there. I'll see you there.